Good morning, children. So, continuation of exercise 8.1, question number 9. So, it is given that ABCD is a parallelogram in which 2 points P and Q are taken on the diagonal BD such that DP equals to BQ. Now, to prove triangle ABD congruent to triangle CQB. Number 2, AP equals to CQ, and then number 3, triangle AQB congruent to triangle CPD. Number 4, AP equals to CP, and then number 5, ABCQ is a parallelogram. Now, so it is given that the given figure ABCD is a parallelogram where it is given that DP equals to BQ. So it is BQ equals to DP. So it is given. And then ABCD parallelogram, here the opposite sides are equal. So it is given. Now, here the first one, you have to prove that triangle ABD. So ABD congruent to triangle CQB. So these two triangles you will prove congruence. As this figure is a parallelogram, so here AD and then BC, and then the diagonal is BD. So this is D, this is B. Now, since the figure is a parallelogram, that is why the opposite pair of sides are equal as well as parallel. Here now AD is parallel to BC, and then here BD is the diagonal. So you will get these two angles equal, as you know that they form a pair of alternate angles. So these two will form a pair of alternate. Now in these two triangles you will get, that is triangle ABD, so APD, so this triangle, and the triangle CQB, so this triangle. In these two triangles you will get their corresponding parts. So BC equals to AD, because they are the opposite sides of the parallelogram, and here DB, so you got here DB equals to BQ, so BQ, that one is given. So DB equals to BQ, this one is given. Then next one is that you will get these two angles equal because they form a pair of alternate angles. Angle CBD, so CBD, that means CBQ. So you will get this angle equals to angle ADB. So you will get these two angles equal. They will form a pair of alternate angles. That is why these two triangles are congruent by side, angle, side. So now, since these two triangles are congruent, that is why you will get AB equals to CQ. This is by CPCD, corresponding parts of congruent triangles. Then you will be coming to the third one, as like number 1. So now the proof. So in the triangle ABD, and triangle CQB, so CQB, so you get in these two triangles you will get that AD equals to CB. So AD equals to CB. So these two opposite sides. So they are the opposite sides of the parallelogram. Opposite sides of parallelogram are equal. So they are equal. Because ABCD is a parallelogram, that is why their opposite sides are equal. Next you get that since the figure is parallelogram, that is why the opposite pair of sides are parallel. Here BC is parallel to AD, that is why you will get these two angles equal. They form a pair of alternate angles. So angle ADP, so angle ADP is equal to angle, so CBQ. So here CBQ. So these two angles are now equal. So they form a pair of alternate angles. alternate angles. Then you have got in both the triangles here DP equals to BQ. So that one is given. So here DP is present in the triangle ABD, so DP, and here BQ. So that is present in the triangle CQB. So DP equals to BQ. This one is given. So you have got the three condition. Therefore, triangle ABD congruent to triangle CQB. So CQB by. So in this triangle, so you took the side AD. So you took this side AD, and you took the side DP, and you took this angle ADB. So you took this angle and these two sides. That is, the two triangles are congruent by side, angle, side. So by SAS. So by SAS, the triangles are congruent. So number 2, as these two triangles are congruent, so that means their corresponding parts are also equal. So from this you will get AP equals to CQ. So here is AP from the triangle ABD. So you will get AP equals to, and from the triangle CQB you will get CQ. So it is CQ by CPC, corresponding parts of congruent triangles. So you have got the first two proof. Now comes the triangle AQB. So AQB congruent to triangle CPB. So these two triangles you will make congruence. So now in this triangle you will get so in number 3, so in triangle, so AQB and triangle CPB, so CPD. So in these two triangles you will get that AB equals to CD. So here AB equals to CD, opposite sides of parallelogram are equal. Then next you have got in the triangle ABQ you have got BQ, and in the triangle ACBD you have got BB. So here BQ equals to BB, that one is given. So you have got it here, that one is given. So now, so here AB equals to DC. So it is C. So AB equals to CD. Why? Because opposite sides of parallelogram are equal. Opposite sides of a parallelogram are equal. So the first condition. Then in the next one, since the figure ABCD is a parallelogram, AB is parallel to DC. If you get here AB is parallel to DC and here BD is the diagonal, so here B and D, you will get these two angles equal because they form a pair of alternate angles. That is why these two angles will be equal. So you will get angle ABQ. So this angle equals to angle CDP. So you will get these angles equal because they form a pair of alternate angles, because here AB is parallel to DC. So angle ABQ, so ABQ equals to angle CDP. So CDP, because here AB is parallel to DC because the figure is parallelogram, and that is why they will form a pair of alternate angles. So it is alternate angles. Then the last condition. So in both the triangle, so you have got BQ equals to DP. So these two is given, so they are now equal. So it is given in the question. So here DP equals to BQ. So BQ equals to DP. So this one is given. So you have got the three conditions. Therefore, triangle AQB congruent to triangle CPD by, so now in these two triangles, so you took here the side AB, you have taken the side BQ, and you took this angle, that is ABQ, so ABQ. So the two triangles are congruent by side, angle, side. So by SAS, the triangles are congruent. Then from this you can get that since the two triangles are congruent, that is why their corresponding parts are equal. So you will get AQ equals to CB. So here AQ equals to CB. This is proof number 4. So here AQ equals to CB because the triangles are congruent. So you will get it by CPCD, corresponding parts of congruent triangles. Then the last proof is that proof number 5, APCQ is a parallelogram. So as I have told you that for a quadrilateral to be a parallelogram, you need 4 conditions. Out of these 4, any one condition must prevail. One is that if both the pairs of opposite sides are parallel, then this BC is parallel to AD or CD is parallel to AB. In that case, the quadrilateral will be a parallelogram. Next condition, if you get both the pairs of opposite sides equal, that is BC equals to AD or BC and AB are equal, that means both the pairs of opposite sides are equal. In that case also, then the given figure becomes a parallelogram. Then the third condition is that if one pair of opposite sides equal as well as parallel, that means only a single pair must be equal as well as parallel. That means BC equals to AD or BC parallel to AD. So just a single pair of means opposite sides equal as well as parallel. Then that figure also becomes a parallelogram. And the last condition, if the diagonals bisect each other, if both the diagonals bisect, in that case also the quadrilateral becomes a parallelogram. Now here they have told you to prove ABCQ is a parallelogram. So out of these 4 conditions, one of the conditions must exist. So now you see here, you have proved that both the pairs of opposite sides are equal. That is in proof number 2 and in proof number 4. Just now you have proved proof number 2, proof number 4. You have got that AP equals to CQ. You have got it by CPCD. That means you have made these two triangles congruent in proof number 1. And then you have got AP equals to CQ, that is by CPCD. And then the next one, you have proved triangle AQB congruent to triangle CPD. You have proved these two triangles congruent. So from there you got AQ equals to CP. That means from 2 and 4 you have seen that both the pairs of opposite sides are equal. That means CQ equals to AB. So CQ equals to AB. This is just the one pair. And then you have got the next pair. That is AQ equals to CP. So here means AQ equals to CP. You have got both the pairs of opposite sides equal. So from this condition, as both the pairs of opposite sides are equal, from proof number 2 and 4, you can say that quadrilateral ABCQ is a parallelogram. So now proof number 5. So in quadrilateral, so ABCQ, so ABCQ, so ABCQ, so you have got that AP equals to CQ, AP equals to CQ, so here AP equals to CQ, so this is the opposite pair of sides equal, and the next pair AQ equals to CP, so here AQ equals to CP. You have got this second pair also equal. So you got that AQ equals to CB. Both are proved above. You have proved in 2 and 4. So proved above. Proved above. So from these two conditions, as both the pairs of opposite sides are equal, therefore quadrilateral ABCQ is a parallelogram. Is a parallelogram. So it is proved. So it is proved. So in the first one, they have told you to prove the triangle ABD congruent to triangle CQB. You have proved these two triangles congruent by side angle side, because BC equals to AD. First reason, that is the opposite sides of parallelogram, and then BQ equals to DB, that one is given, and then since BC is parallel to AD, because ABCD is a parallelogram, that is why these two form a pair of alternate angles. That is why the triangles are congruent by side angle side. Therefore CQ equals to AB, that is by CBC. Then next we have proved triangle AQB congruent to triangle CPD. So these two triangles you have proved the congruence by side angle side. So side angle side, because AB equals to CB, opposite sides of parallelogram. Then you got BQ equals to DB, that one is given, and then you have got that AB is parallel to DC. That is why these two angles form a pair of alternate angles. That is why these two triangles are congruent by side angle side. So from there you have got AQ equals to CP by CPCD. Now the last proof, you have to prove that ABCQ. So ABCQ. So these figures should be a parallelogram. So as I have told you that there are 4 conditions. Out of these 4, you have used this condition that if both the pairs of opposite sides are equal, then that quadrilateral will be called a parallelogram. So since you have got AP equals to CQ, so here AP equals to CQ, and then AQ equals to CP. So these two are equal. Since both the pairs of opposite sides are equal, that is why ABCQ is a parallelogram. So it is proved. Number 11, question number 11. So it is given that AB equals to DE, then AB is parallel to DE, then BC equals to EF, then BC parallel to EF. Then the figure is given. Now to prove, so here given 1 is given that ABED is a parallelogram. Number 2, DEFC, so DEFC is a parallelogram. Number 3, AD parallel to CF, then AD equals to CF. Number 4, so it is given that AFCD, AFCD, ACFD, sorry, is a parallelogram. Parallelogram. Then number 5, AC equals to DF. And number 6, you have to prove triangle ABC congruent to triangle DEF. So DEF. So here this is given AB equals to DE. AB is parallel to DE, and then BC equals to EF, and then BC is parallel to EF. Now the given things here, AB equals to DE, and then BC equals to EF. So here BC equals to EF. So this one is given. Now to prove that ABED, so ABED is a parallelogram. So as I have told you that to be a parallelogram, one of the 4 conditions must prevail. So now let us see. So in this quadrilateral ABED, so ABED, you have to prove that ABED should be a parallelogram. For this, you have to show either both the pairs of opposite sides must be parallel, or both the pairs of opposite sides must be equal, or at least means one pair of opposite sides equal as well as parallel. So out of these 3, you have to show any one. Let us now see in ABED. So they have given that AB equals to DE. So here these 2 are equal, opposite pair of sides. Also they have given that AB is parallel to DE. So here now one pair of opposite sides equal as well as parallel. You have seen that this is a single pair ABDE. Once it is equal, once it is given parallel. That means if in a quadrilateral one pair of opposite sides equal as well as parallel, then that quadrilateral will become a parallelogram. So from these 2 conditions, you will get that ABED is a parallelogram, because here AB is equal to DE, AB is parallel to DE. You have got the single pair of opposite sides equal as well as parallel. So now here proof 1. Proof 1 in quadrilateral. So ABED. So ABED. So you have got that AB equals to DE. So it is given. It is given. Also it is given that AB is parallel to DE. So AB is parallel to DE. So this is also given. So you have seen from this 2 that a single pair of opposite sides equal as well as parallel. That is why the given quadrilateral ABED is a parallelogram. So therefore ABED is a parallelogram. Parallelogram. Reason is since one pair of opposite sides, one pair of opposite sides are equal and parallel. Equal and parallel. So that is, if a single pair of opposite sides you get equal as well as parallel, then that quadrilateral becomes a parallelogram. So as you have seen in proof number 1. Then comes the next one, BEFC is a parallelogram. So BEFC, so this figure. So now let us see, they have given BC equals to EF. So here BC equals to EF. This is the opposite pair of sides given as equal. Again they have given BC is parallel to EF. So this BC is parallel to EF. That means using this f of 2, you can get that since the single pair of opposite sides equal as well as parallel, therefore BCEF is a parallelogram, because a pair of opposite sides is equal as well as parallel. now in proof number 2, so it is number 2 in quadrilateral. So it is BEFC. So BEFC. So you got BEFC. So it is given that BC equals to EF. So BC equals to EF. This one is given. So it is given in the question. Next is BC is parallel to EF. So BC is parallel to EF. This is also given. Now you see, you have got a pair of opposite sides that is equal as well as parallel. Therefore, BEFC is a parallelogram. So here the reason is the same. Since one pair of opposite sides equal and parallel. So that is why the first and the second that is the same. So they have given. Now comes the proof number 3. AD is parallel to CF. AD equals to CF. Now from this, how to get proof number 3? So you have proved in 1 and 2. So now it is 3. Proof number 3. AD is parallel to CF. AD is parallel to CF, and then AD equals to CF. AD and CF equal. So to get this, you will have to go back to 1 and 2 that you have proved. So in the first case, you got that ABED is a parallelogram. So ABED, since this is a parallelogram, that is opposite sides equal as well as parallel. So now from this you will get, from this first one, that AD, so AD is parallel to BE. So here AD is parallel to BE, and then you get AD equals to BE. Why? Because ABED is a parallelogram. ABED is a parallelogram. As you know that in a parallelogram, opposite sides are always equal and parallel. That is why, since ABED is a parallelogram proved above here, that is why the opposite pair of sides are equal. AD equals to BE, and then AD is parallel to BE. You have got it from 1. Since ABED is a parallelogram, so this is equation number 1. Then the next one, BEFC. So BEFC, this is also a parallelogram. So from this you have got that the opposite pair of sides are equal as well as parallel. So from this you will get that here BE parallel to CF. So parallel to CF, and then you will get BE equals to CF. So BE equals to CF. Why? Because BEFC is a parallelogram. So BEFC is a parallelogram. So this one is equation number 2. Let us take the first one. How we have got this? AD is parallel to BE. So AD is parallel to BE. AD equals to BE. Because you have proved in 1 that ABED is a parallelogram, and in a parallelogram, opposite pair of sides are equal as well as parallel. That is why, since the figure is a parallelogram, so from this you got that AD equals to BE, and then AD is parallel to BE. So you got it from 1. Next, in the second part, you have proved that BEFC is a parallelogram. So from this also you have got that the opposite pair of sides are equal as well as parallel. So that is why you have got that BE parallel to CF, and then BE equals to CF. Now you compare 1 and 2. So from 1 and 2 you will get. So from 1 and 2. So we get. Now you compare these parallel parts between these two and between this equality part. So between these two equations. So from these two, you will get that AD is parallel to BE, BE is parallel to CF. So here BE is present in both the equations. So here AD is parallel to BE, BE is parallel to CF. That means all these three lines are parallel, which means that AD is parallel to CF. Because here BE is parallel to AD, BE is parallel to CF, which means AD is parallel to CF. So you will get AD is parallel to CF. And then from these two equations, you will get that AD equals to BE, BE equals to CF. So you see here BE is present in both the equations. That means AD equals to CF. So you will get AD equals to CF. So from this you have got proof number 3. So in this one you have got that AD is parallel to CF because BE is parallel to both AD as well as CF. So comparing these two equations, you have got that AD is parallel to CF, and here BE equals to CF, BE equals to AD, and from these two you have got AD equals to CF. So you have got proof number 3. Now comes ACFD is a parallelogram. Now proof number 4. So you take proof 4. So here in quadrilateral, so ACFD. So you see, you have to prove that ACFD to be a parallelogram. So that means just to see that if you get a pair of opposite sides equal as well as parallel, then the figure will become a parallelogram. Now you see in this proof number 3, you have proved that AD parallel to CF. So this pair of opposite sides is parallel, and then the same pair of opposite sides equal. So AD equals to CF. That means you got this pair of opposite sides equal as well as parallel as proved in 3 above. So from this condition, you have got that ACFD is a parallelogram, because a quadrilateral becomes a parallelogram if a pair of opposite sides is equal as well as parallel. That is why here ACFD is a parallelogram. So now AD parallel to CF, and then you have got AD equals to CF. So this one is proved above. So proved in 3 above. So in 3 above. So here a pair of opposite sides you got parallel as well as equal. Therefore ACFD is a parallelogram. So now next one is AC equals to DF. This is proof number now 5. So comes proof number 5. So you can easily say AC equals to DF. So since ACFD is a parallelogram, just now you have proved in 4 above. So since this figure has become a parallelogram, that is why the opposite sides are also equal. So you got AC equals to DF. You can say that opposite sides of parallelogram. Opposite sides of parallelogram ACFD are equal. So that is why AC equals to DF. Because you proved in 4 that ACFD is a parallelogram, that is why AC equals to DF, opposite sides of means parallelogram. Now, last one is 6. So in proof number 6, you are to prove that triangle ABC congruent to triangle DEF. So in triangle ABC, in triangle ABC and triangle DEF. So from both these two triangles, so ABC and DEF, so from these two triangles, what can you see? Because you will make these two triangles congruent. So they have given that AB equals to DE. This one is given in the question. So it is AB equals to DE. This one is given in the question. So AB from the triangle ABC and then the side DE from the triangle DEF. Then they have given BC equals to EF. So here BC equals to EF. So BC equals to EF. This one is also given. Then one last one, that is AC equals to DF. So AC equals to DF. So these two are equal because you have proved it 5. So here AC equals, so here AC equals to DF. So DF as proved in 5 above. So you have got it as proved in 5 above. So 5 above. So you have got the 3 condition. Therefore triangle ABC congruents to triangle DEF. So by side. So by SSS condition. So in this proof, the main point is that you have made 3 quadrilaterals into a parallelogram. So the condition used was if a pair of opposite sides equal as well as parallel. So there were 4 conditions. So here you have used only the single condition, that is a pair of opposite sides is equal as well as parallel. In that case the quadrilateral becomes a parallelogram, and the remaining things you can just deduce from the previous proofs. So in that way you have proved that triangle ABC congruents to triangle DEF. So in these two triangles you have got that BC equals to EF. This one is given in the equation, and here AB equals to DE. This one is also given, and then AC equals to DF. This one is proved above. So it proved in 5 above. So the two triangles are congruent by side. Let us take 12. Question number 12. So here it is given that ABCD is a trapezium in which AB is parallel to CD, and AD equals to BC. Now to prove number 1, angle A equals to angle B. Number 3, angle C equals to angle D. Number 3, triangle ABC congruents to triangle BAD. And the last one is AC equals to BD. Now, This is very important sum. So here they have given that. So here ABCD is a trapezium. So this is a trapezium such that AB is parallel to CD. So here AB is parallel to CD. So this pair of opposite sides are given as parallel, and then AD equals to BC. So this opposite pair of sides are given as equal. You have to prove that angle A equals to angle B. So these two angles must be equal. Then number 2, angle C equals to angle D. So these two angles, so C and D. So these two angles must be equal. And then triangle ABC. So ABC, that means by joining AC and then BD, by joining diagonal AC and then diagonal BD, you will get triangle ABC, and by joining BD, you will get triangle BAD. But now for the timing, we are not going to join. So that will be construction. So here, then the last one is that AC equals to BD. That means you will make this length of the diagonals equal. That is the last proof. Now, so the given figure is a trapezium where AB is parallel to DC, that is given, and then AD equals to BC. Opposite pair of sides are given as equal. So here, what you will do is, here you will do construction. So here, first, through this point C, we will draw a line parallel to AD. So through this point C, you will draw a line that will be parallel to AD, such that the line will meet AB produced. So say here, through C, you have drawn a line parallel to AD. So this is a line. So now that will meet. So the side AB produced, extended, say at point E. So now here you will write construction. So here, so through C, you have drawn the line CE, making it parallel to AD, such that they will meet the side AD produced at point E. So through C, comma, so CE parallel to DA is drawn, to meet the side AB produced at point E. So here now comes the proof. So let me tell again that through this point C, you have drawn this line parallel to AB, such that will meet the side AB at E. Now they have given that AB is parallel to DC. They have given that AB is parallel to DC. But the side AB is produced to point E. That means you can say that if AB is parallel to DC and then AB is extended to point E, in that case also from this you can say that AE is parallel to DC. So AE is parallel to DC. So from this you can say, since AB is parallel to DC, therefore AE is also parallel to DC. Next, through this construction, you have made CE parallel to DA. So CE parallel to DA. So CE parallel to DA. Now from these two conditions, you have seen that AE parallel to DC and CE parallel to DA. That means both the pairs of opposite sides are parallel. Therefore, AECD is a parallelogram. So, as both the pairs of opposite sides are parallel, so this is one of the conditions for a quadrilateral to be a parallelogram. Since here both the pairs of opposite sides are parallel, so from this you have got, that is why AECD is a parallelogram. So that is why AD equals to CE. So therefore AD equals to CE. So you have got, because opposite sides are equal. Next, they have given AD equals to BC. This one is given. So you got that AD equals to BC. This one is given here. So by comparing these two equations, so AD equals to CE, AD equals to BC. So in place of AD you can write CE. So in place of AD I wrote CE because they are equal. So CE equals to BC. So you got these two. So CE equals to BC. So you have made these two sides also equal. Now let us take, for your convenience, that, and here in the construction part you will write AC and BD are joined. So AC and BD are joined. But for now I will not join so that it will be more clear. Now comes proof. So here in quadrilateral, so AECD, so AECD, so AE is parallel, so AE is parallel to BC. Why? Because it is given that AB is parallel to CD. So AB is parallel to CD. That is why since the side AB is produced to E, that is why AE also is parallel to DC. So since here AB is parallel to DC, that is why you got AE parallel to DC. Then you have made CE parallel to DA. So CE parallel to DA. Why? This one you have got it through this construction. So this is through construction. Now from these two condition, you have got that as both the pairs of opposite sides are parallel. So therefore you will get AECD. So AECD is a parallelogram. So from this you have got that AECD. So AECD is a parallelogram. Now, so therefore, since this is a parallelogram, that is why the opposite sides are equal. So AD equals to CE. Therefore, AD equals to CE. This is opposite sides of parallelogram. Opposite sides of parallelogram are equal. Also, it is given that AD equals to BC. This one is given in the question. So AD equals to BC. So AD equals to BC. This one is given. Now from these two equations, you can say that, so in place of AD you can write CE because they are equal. So in place of AD you can write CE. So CE equals to BC. Now here you see CE equals to BC. So this is a triangle. Opposite sides are equal. That is why from the theorem you have got that if the opposite sides are equal, then their opposite angles are also equal. So you take here angle 1, angle say 2, this is 3, let us give 4, this is 5, and let it be 6. Now, so therefore, since in this triangle BCE you got CE equals to CB, so you have got this one. So the opposite sides in this triangle BCE are equal. That is why their opposite angles are also equal. So therefore angle 1 is equal to angle 2. So since angles opposite to equal sides, you have got it from the theorem. Angles opposite to equal sides. Equal sides. Now, here, for the proof 1, let us take the proof 1. So, now they have said you want to prove angle A equals to angle B. So, to prove that means angle 3 equals to angle 4. Now you see here that since here AB is parallel to DC, since here that means AE and DC are parallel, and this is the line, so it is C, this is B. In that case, you can say that 5 and 1 will be equal. That is the alternate interior angles. So, but now, in this case, we will take this way, that these two form a pair of, means linear pair, they are adjacent. So, these two. So, here, angle 1 plus angle 3 equals to 180. So, because they form a linear pair. So, it is linear pair, linear pair. Let it be equation number 1. So, next one is here. AD is parallel to EC. So, here AD is parallel to EC because this given figure has become a parallelogram. That is why opposite pair of sides are equal as well as parallel. How that has become a parallelogram? Here, because both the pairs of opposite sides are parallel. So here AD is parallel to CE. That is why this angle plus this angle you will get 180 degree co-interior angles. So here then angle 4 plus angle 2 equals to 180. So since sum of adjacent interior angles is 180 degree. So since our AD is parallel to means CE, that is why these two angle total sum will be 180 degree. Now you compare, let it be equation number 2. Now you compare 1 and 2. So from 1 and 2 you get both their total sum is 180 degree. So these two sides also will be equal. So here angle 1 plus angle 3 is equal to angle 4 plus angle 2. So this gives, now you need angle A equals to angle B. So these two angles must be equal. That is angle 3 is equal to angle 4 unit. So you need to make these two angles equal. But here 1 and 2 is equal. You have got it here. So these two angles are equal because their opposite sides were equal. That is why from that theorem you have got that the opposite angles also are equal. So you got here angle 1 plus angle 3 is equal. So in place of angle 2 you can write angle 1. So here since angle 1 is equal to angle 2, so in place of 2 you have got 1. So these two got cancelled. So from this you have got that angle 3 is equal to angle 4. So you got here angle 3 is equal to angle 4. So therefore angle A is equal to angle B. So the first proof you have got. Now the second proof is that you are to prove angle C is equal to angle D. That means angle 5 is equal to angle 6. Second one. So to get the second proof, now you see here AE is parallel to DC because the figure is parallelogram. Already they have given AB is parallel to DC. So from here you get that AE is parallel to DC. So that is why angle 5 is equal to angle 1. So there we form a pair of alternate angles. So angle 5 is equal to angle 1. It is alternate. So it is alternate angles. Then angle 5 means angle C. So this will be same. Angle 5 is equal to. But angle 1 equals to angle 2. So you have proved here angle 1 is equal to angle 2. So in place of angle 1, you will take angle 2. Since angle 1 is equal to angle 2, then so angle 5 is equal to. Now since AECD is a parallelogram, so in a parallelogram opposite angles are also equal. So here opposite of 2 is angle 6. Then so these two angles also will be equal. So in place of angle 2, you can take angle 6. So angle 6. Since angle 2 is equal to angle 6, because in a parallelogram, opposite angles are equal. So you got angle 5 is equal to angle 6. That means angle C is equal to angle D. So you got that angle C is equal to angle D. Now you are to prove triangle ABC congruence to triangle BAD. So for this, now you will join AC and BD. This is through construction. So comes number 3. In triangle ABC, so ABC and triangle BAD, so BAD. So in these two triangles, so one is triangle ABC. In the triangle ABC, you got angle B, that is angle 3, and in the triangle BAD, you got angle 4. So in triangle ABC, you got angle 3. So angle 3 is equal to angle 4 from this triangle. That is proved above. Yes, angle 3 is equal to angle 4. Then next, in the triangle ABC, you got the side BC. So BC equals to AD. So these two sides, so they have given as equal. So that is given in the equation. So equals to AD. This one is given. Then in both the triangle, you have got one common base, that is AD. AD is there. So these two triangles, they have the common base AB. So here AB equals to AB. So AB equals to AB. That is the common side. So you have got the three conditions. So if we take triangle BAD, so you took AD, you took AB, and you took angle 4. So you took AB, angle 4, and then the side AD. So the two triangles are congruent by side, angle, side. So therefore triangle ABC congruence to triangle BAD. This is by SAS. So as the two triangles are congruent, so that is the last one. So since triangle ABC congruence to triangle BAD, so in ABC you got AC, and in the triangle BAD you got BD. So as these two triangles are congruent, so you got AC equals to BD. So AC equals to BD, CPCT. So it is